Supreetha. Welcome to my math class. So in the previous lectures on limits, we studied the concept of limits. Yes, and then we solved some JEE mains problems. Correct? So in the previous video, we solved JEE Advanced problems, right? So this is a continuation of that video. Here we are solving the third question. In this third question, they are asking us to match the limit values, okay, from the LHS to RHS. Okay, so for that, let me write down the first question. Okay, so the first question is limit x tending to pi by 4 sine 2x to the power tan square 2x. Right? So now what do? I have this question in the form of a power b. So whenever you find something to the powers of something, try taking or try plugging in log function. Okay. So now let me take y is equal to the given question, that is limit x tending to pi by 4 sine 2x to the power tan square 2x. Okay. Now if I take log on both the sides, what would I get? Log y is equal to limit. Since log is a continuous function, I can take log inside the limit. Yes. So I would get log sine 2x. If you have log a power b, can you write it as b log a? Yes. So here I have log sine 2x to the power tan square 2x. So I write it as into tan square 2x. Now apply the limit to the function. What would you get? I would get sine pi by 2, right? Because in the place of x, if you substitute pi by 4, 2's are 4, right? So you would get sine pi by 2. Now, what is sine pi by 2? 1, right? What is log 1? 0. Yes? Now, what is tan pi by 2? Tan 90 degree? That is infinity. So here you can see that we have an indeterminate forms. What is an indeterminate form? Please go back and check my previous videos for that. Okay, so here we have an indeterminate form. How to solve this? Can you use L'Hospital's rule? No, right? Because we have 0 into infinity. So let us try reducing it to 0 by 0 form or infinity by infinity form. For that, I have a tan here. What? So can we write tan as sine by cos? Yes. So I would get limit x tending to pi by 4 log of sine 2x into sine square 2x divided by cos square 2x. Now, what is sine pi by 2? Sine pi by 2 is 1, right? Log 1 is 0 and 0 into anything is again 0, right? In the denominator, what is cos pi by 2? Cos pi by 2 is again 0, right? So we have a 0 by 0 form. Let us apply the L'Hospital's rule. What does the L'Hospital rule say? Differentiate the numerator and then differentiate the denominator. Correct? So let me take the numerator and differentiate it. So we are differentiating it with respect to x. Yes, we have log of sine 2x into sine square 2x, right? So now what would we get? We have two terms here, right? So let me apply the product rule. That is, let me keep log of sine 2x as it is. Yes. Now differentiation of sine square 2x. That is 2 sine 2x into d by dx of sine 2x. Yes. Now again plus, since it is a product rule, it is a plus. Yes. Now Let me keep sine square 2x as it is and differentiate log of sine 2x. That is 1 divided by sine 2x into dy dx of sine 2x. Okay. So yes, the sine 2x and the numerator sine 2x gets cancelled, right? What would we get? Log of sine 2x into 2 sine 2x, we can write it as it is, and differentiation of sine 2x is 2 cos 2x. Okay, here we have sine 2x. What is differentiation of sine 2x? That is 2 cos 2x, right? Now, can you take anything common here? Observe. Yes. Can I take 2 sine 2x into 2 cos 2x common? Yes. So what else is remaining? Log of sine 2x plus 1. Now if I take this as equation 2 and if I take, okay, if I take this as equation 1, yes, so basically I'm applying the L'Hospital's rule, okay. So from the L'Hospital's rule, I would get limit x tending to pi by 4. Yes, what is differentiation of log of sine 2x into sine square 2x? That is 2 sine 2x. Okay, so let me write 2 into 2 as 4, okay. So yes, 4 sine 2x. Yes, into cos 2x into log of sine 2x plus 1 divided by, yes, what is differentiation of cos square 2x? Differentiation of cos square 2x is, so you would get 2 cos 2x, yes, and then differentiation of cos 2x. What is differentiation of cos 2x now? Differentiation of cos 2x is minus 2 into sine 2x. Yes, so let me write that down. I would get in the denominator 2 into 2 is 4. I would get sine 2x into cos 2x. Now you see here we have taken 4 common, right, which is not possible because we have only 2 here, right? So let me replace this with 2, okay? Yes. Did we miss anything? We would get a 2 over here because there was a 4, right? So now what next? So as you can see, sine 2x, cos 2x, these both gets cancelled and 2 ones are, 2 2's are goes away. Yes. So what else is remaining? Limit x tending to pi by 4. Yes, we have 2 log of sine 2x plus 1 divided by 2, and we have a negative here. So now divide negative, okay, divide 2 for both the terms, right? So I would get minus log sine 2x minus half. Yes. Now, what is sine 90? 1, right? If you apply the limits, sine 90 is 1. Agree? So, what is log 1? 0. And we don't have any x term here, so we can write minus half. So, we have log y is equal to minus half. Now what would y be? Y is e to the power minus half, right? So that is our option C, right? This is the first one. So now let me write down the second one, okay? So this is the second one. We have limit x tending to infinity, 2x minus 1 divided by 2x plus 1 to the power x. So whenever you have to the power something, try plugging in log function. It would make your job easier. Okay. So now, let me solve this by taking, yes, I'll take y is equal to the given question. I'll take log y. Yes, what would I get? Limit x tending to infinity, x into log of 2x minus 1 divided by 2x plus 1. Okay. So now, you see, after applying the limits, what would we get? We would get infinity. Yes, we would get infinity into, this is log infinity. Yes. So yes, you see here, if you apply the limits, what would you get? You would get infinity because you have a x here. Yes. Now to solve this, okay, let me take out x common in the numerator. I would get, what would I get? 2 minus 1 divided by x divided by, again, x common, 2 plus 1 divided by x. X and x gets cancelled. Yes, we have a log here. Agree? What would you get if you apply the limits now? If you apply the limits now, you would get log 1. How? 1 divided by infinity is 0, right? Even in the denominator, 1 divided by infinity is again 0. You would get 2 divided by 2. What is log 1? Okay, so that is why you would get log 1. Now what is log 1? Log 1 is 0, right? So again, this is an indeterminate form. Okay, so since it is a infinity into 0, let me take this x to the denominator. Okay, what would I get if I take x to the denominator? Log of 2x minus 1 divided by 2x plus 1 divided by, I can write it as 1 divided by x, right? So what is 1 divided by infinity? 0, right? So we know that this log of this term, it is 0. And even in the denominator we have 0. Now we can apply L'Hospital's rule. Yes, to apply L'Hospital's rule, let me differentiate the numerator term. Okay, that is log of 2x minus 1 divided by 2x plus 1. Yes, let me find the differentiation of this term. So what is differentiation of log x? Differentiation of log x is 1 divided by x, right? So I would get 1 divided by 2x minus 1 divided by this. If I take that term to the numerator, you would get the reciprocal, that is 2x plus 1 divided by 2x minus 1. Now we would have to differentiate this term again, right? That is this term. Yes, so if you have differentiation of log of f, you would get 1 divided by f into f dash. Yes, this is a formula, right? Remember? So now, differentiation of this function. Okay? So what is differentiation of f divided by g? Wasn't it g into f dash minus f into g dash divided by g square? Agree? So in the place of f we have 2x minus 1 and in the place of g we have 2x plus 1. Right, so what would we get? We would get g. What is g? 2x plus 1. Yes, differentiation of 2x minus 1 is 2, right? Minus, write down f as it is, okay? And the differentiation of 2x plus 1 is 2, right? So divided by, I would get 2x plus 1 the whole square. So yes, as you can see, we can take 2 common here, right? Let me do that. So we would get 2x plus 1 divided by 2x minus 1 as it is, okay? And we have 2 into 2x plus 1 minus 2x plus 1 divided by 2x plus 1 the whole square. Yes, the numerator 2x plus 1 and the denominator gets cancelled. Okay, so here 2x and 2x gets cancelled. So what else is remaining? We have 1 plus 1, that is 2. Yes, 2 into 2 is 4. So can I write it as 4 in the numerator? These are the remaining terms. Yes, and in the denominator you can see we have 2x plus 1 into 2x minus 1. So we have a plus b into a minus b. So what is a plus b into a minus b? A square minus b square, right? So that is, we would get 2x the whole square, that is 4x square minus 1. Okay, so let me apply this over here. Yes, let me substitute this. So after applying L'Hospital's rule, we would get limit x tending to infinity. So in the numerator we have 4 divided by 4x square minus 1, and in the denominator, as you know, differentiation of 1 divided by x is minus 1 divided by x square. How did we get this? Differentiation of x power n is n into x to the power n minus 1. Okay, so we have minus 1 divided by x square. Yes. So now let me take this x square to the numerator. What would I get? Limit x tending to infinity minus 4x square divided by 4x square minus 1. Okay. So now in the denominator, let me take 4x square common. Minus 4x square divided by 4x square. If I take that as common, I would get 1 minus 1 divided by 4x square. Okay, so as you can see, from the numerator, 4x square and the 4x square in the denominator gets cancelled. Now, if I apply the limits, what would I get? So I would get minus 1 divided by 1 minus 1 divided by infinity, right? That is minus 1. So we have log y is equal to minus 1. Now what is y equal to? On taking anti-log, we would get y is equal to e to the power minus 1. That is our option A, right? So obviously the third one must be option B. Yes. So let us solve this third one in the next class. Let's revise what we studied in this video. Yes. That is, we took the first question, that is limit x tending to pi by 4 sine 2x to the power tan square 2x. So anything if you get like a to the power b, try plugging in log into that. Yes, so we plugged in log, and since we have log a power b is equal to b log a, we used that and we saw that we were getting 0 into infinity form. Yes, since it is an indeterminate form, we simplified it to get a 0 by 0 form, and then we applied the L'Hospital's rule. Okay, so after applying L'Hospital's rule, we arrived at our answer, which was option C. Okay, So for the second problem, yes, again we used the same thing, that is we took log on both the sides. Yes, we got 0 into infinity. After some simplifications, we got 0 by 0 form. And after differentiation, we arrived at y is equal to e power minus 1. That is our option A. Okay, so that is it for today's class. Thank you.